Okay, so I'm just going through 3 exam questions that I was asked to help with. So I was asked to help with the second part of this question, but it helps to explain it if I do the first part. So expand w times w plus 6. Now that's just the w times everything that's inside the bracket. So w times w gives us w squared, and w times 6 gives us 6w. So that's simple enough. Now the second part of the question is just really the reverse of that process. So we've got to think about putting 8y plus 20 into something times a bracket. So very much the reverse of what we did in the first half. And first of all, we need to think of a number that goes into both 8y and 20. And that number is 4. So 4 goes outside the bracket, and then we need to think, okay, so 4 times what will give us the 8y, and 4 times 2y will give us 8y, and then 4 times what will give us the 20. And of course 4 times 5 makes 20, so the factorization is 4 times brackets 2y plus 5. So this is not to be confused with quadratic factorization, where you're looking for factors of something that add up to something else. This is much simpler. There's no quadratic term in there. There's no x squared or y squared or anything squared. So it's a much simpler process than when you have to factorize a quadratic. Okay, the next question is a quadratic, and because the first term, it's not just n squared, but it's 3n squared, then you can't apply the process of finding factors of something that add up to something else. And it's a little bit more trial and error. Now you need to think that this is going to factorize into 2 brackets, and something in the 2 brackets has got to multiply out to give you 3n squared. Now because 3 is a prime number, there's only really one possibility for that, and that's 3n times n. So there's going to be a 3n in one of the brackets and an n in the other bracket that's going to multiply together to give you a 3n. Now we need to look at the 4. There's going to be 2 numbers that multiply together to give you 4. Now there are a few possibilities for that. It could be 1 times 4, or 2 times 2, or 4 in the first bracket and 1 in the second bracket. So that will be different, because in one case the 3n will get matched up with the 1 and the n with the 4, and in another case it'll be the other way around. So 1 times 4 and 4 times 1 in different brackets are different cases. There's also more possibilities. You could have -1 times -4, -2 times -2, or all sorts of things with decimal numbers. But because this is an exam question, it probably won't go into decimal numbers, and because there aren't any minuses anywhere in the original thing, it's probably not going to involve minuses. So we just need to see which ones of these work. So first of all, I'm going to try the 3n times the n in the first and second brackets, and then match that up with the 1 and the 4. So 3n plus 1 times n plus 4. So we know the 3n times n will give us the 3n squared. We know the 1 times the 4 will give us 4. But then when we multiply it out, we've also got 2 middle terms, because we've got the 1 times the n gives us n, and we've got 3n times 4 gives us 12n. So that multiplies out to 3n squared plus 12n plus n plus 4. The 2 middle terms, of course, go together to make 13n. So that multiplies out to 3n squared plus 13n plus 4, which isn't equal to the thing we started with, because that had a 7n in the middle. So I'm going to try another one. I'm going to try having the 3n and the n in the brackets like before, but then match that up with a 2 and a 2. So we know the 3n times n will make 3n squared. We know the 2 times 2 will make a 4, but then we've also got 2 middle terms, a 6n and a 2n, because 3n times 2 makes 6n, and 2 times n makes 2n. So we've got 3n squared plus 6n plus 2n plus 4. The two middle terms go together to make 8n. So 3n squared plus 8n plus 4. But again, that's not the thing we started with because that had 7n in the middle. So I'm going to try the last one. Hopefully, since we haven't got any left to try, this will work. I'm going to try 3n plus 4 times n plus 1. So I've got the 3n and the n in two different brackets multiplying together to make 3n squared. I've got 4 times 1 multiplying together to make the 4. And then the middle terms, I've got 3n times 1 makes 3n. 4 times n makes 4n. And they go together to make 7n. So 3n squared plus 7n plus 4 is the thing I started with. And then we can see that it's the same as 3n plus 4 brackets times n plus 1 in brackets. So to answer the question, factorize it. It factorizes into those brackets 3n plus 4 times n plus 1. So there's a little bit of common sense and a little bit of trial and error involved in that. Okay, the next question I was asked to help with. The diagram shows a rectangle. The sides of the rectangle are x plus 4 and x minus 5. And the area of the rectangle is 90 centimeters. Well, we know how we find the area of a rectangle. We multiply the two sides together. So the information in the question is telling us that x plus 4 times x minus 5 equals the area, 90. So multiplying that out, x squared minus 4 plus 4x minus 5x minus 20 equals 90. And that already is a quadratic equation, but tidying it up a bit, we've got 4x minus 5x in the middle, which together makes minus a single x. So x squared minus x minus 20 equals 90. And then it's easier to solve quadratics if we have everything equal to 0. So I'm going to take away 90 from each side, and then that becomes x squared minus x minus 110 equals 0. So that's answered the first part of the question. We've set up and solved a quadratic equation. Well, we haven't solved it. We've set up a quadratic equation, and we're about to solve it. Now, one way to solve quadratic equations, of course, is the formula. So in the formula, a is the amount of x squared we've got. So a is 1 because we've got just 1x squared. We've got minus x there, or in other words, minus 1x. So b is the amount of that we've got, minus 1. And c is the odd term on the end, which in this case is minus 110. So a general quadratic is ax squared plus bx plus c equals 0, which is why we put it equal to 0, so that it fitted the general pattern, and then we could apply the formula, minus b plus or minus square root of b squared minus 4ac over 2a. That formula will tell us what x is. So we put all those numbers in. X equals minus 1 plus or minus square root of minus 1 squared minus 4 times 1 times minus 110 all over 2 minus 1. There's a lot of minuses there you could get tripped up on, so be careful with that. And it all boils down to 1 plus or minus 21 all over 2. Now that will give you two possible answers, because quadratics usually have two solutions, not always, but usually quadratics have two solutions. And in this case, one of these solutions doesn't make sense in the context of the question, because you don't have a minus length of a rectangle. So in fact, if you work out what x is for those, for that, well, it can either be 11 or some negative number that you're not particularly interested in, minus 10 in fact. But the solution is x equals 11, and the good thing about maths, you can go back to the original question and say does that actually work? Does that make sense? Well, if x is 11, then this side is 11 minus 5, which is 6. And then this side is 11 plus 4, which is 15. So the rectangle is 6 centimeters by 15 centimeters. And that does indeed give an area of 90 centimeters squared.